All right, let's get right into it. Today, we're going to break down a really critical safety procedure, the API653 assessment for brittle fracture in steel storage tanks. Now, I know, that sounds like a mouthful, but trust me, it's an absolutely vital process that prevents some really catastrophic failures. When you boil it all down, this entire standard is really trying to answer one simple question. Is your storage tank, especially an older one, genuinely safe to keep using? Or is there a silent risk just waiting to happen? And believe me, the stakes here are incredibly high. And that risk? That's brittle fracture. We're not talking about a slow leak you can patch up. This is a sudden, catastrophic failure of the steel itself. And here's the kicker. It often happens after something is changed. Maybe a repair was done, maybe it's operating at a colder temperature now, or maybe you've switched the product inside. The takeaway? Just because a tank has been perfectly fine for decades, it doesn't mean it's safe tomorrow. So here's what we're going to cover. First, we'll look at the hidden danger of brittle fracture. Then, I'll show you the decision map that's going to be our guide. We'll walk through the key questions you have to ask, and finally, we'll figure out how to determine if a tank is truly fit for service. Okay, first up, why is this assessment so darn important? Well, because the danger isn't always something you can see. The API standard makes this really clear. Most of the reported failures have happened after some kind of change. We're talking about a repair, an alteration, or maybe the very first time the tank gets filled up in really cold weather. So that old saying, past performance is no guarantee of future results, it's a perfect fit here. And that's exactly why we have this formal assessment procedure in the first place. So, the big question is, how do you manage this risk? Well, the good news is you don't have to guess. The API653 standard gives us a really clear step-by-step procedure to follow. And you should think of it less like some dense, complicated rulebook and more like a logical decision map. It's kind of like a diagnostic chart for your tank's health. It's just a series of yes or no questions that walk you right to a solid conclusion about whether your asset is safe or not. And here it is. This flowchart is basically our roadmap for the rest of this explainer. Now, I know at first glance it might look a little intimidating, but don't worry, we're going to break it down step by step. Just take a look at the overall flow. You've got the diamonds, those are your decision points, and the boxes, which are actions or outcomes. Every single one is a critical checkpoint on the path to figuring out if a tank is safe. All right, so let's see how this thing actually works. We're going to walk through some of the most important checkpoints on this map right now. Okay, the very first question is a huge one. It's basically the first fork in the road. Was the tank originally built to a modern standard? We're talking API 650, 7th edition, or later. If the answer is yes, hey, you're in a fantastic spot. Because those tanks were built with materials and methods specifically designed to prevent this exact risk, and you'll probably get to bypass a whole lot of this assessment. You can see it right there, at the very top of the chart. A yes at step 1 sends you down a much, much shorter path. But a no? Well, a no means we've got more work to do, which, let's be honest, is the case for a lot of the older tanks that are still out there in service today. Okay, let's jump to another key checkpoint, step 4. This one is all about the shell thickness. And this is a really critical factor. Why? Because the standard basically says that for shells half an inch thick or less, the risk of brittle fracture is considered pretty minimal. It's because thinner steel plates just aren't as rigid. They're inherently tougher and not as likely to have that sudden, catastrophic crack we're trying to avoid. So if your tank shell is on the thinner side, the assessment is often super straightforward. You can pretty much go right to the continue to use box. Next up, let's talk about temperature. Step 5 gives us a simple but really powerful rule of thumb that's based on decades of real-world experience. And it is this: no known brittle fracture failures have ever happened in these kinds of tanks when the shell metal was warmer than 16 degrees Celsius or 60 degrees Fahrenheit. So if you know for a fact your tank never, ever gets colder than that, it's considered safe from this particular problem. But what about all those older tanks that don't pass those first few simple checks? Well, for them, the whole assessment pretty much comes down to one critical tool, and it's called the exemption curve. And this slide shows you the process perfectly. See step 7 over there in our flowchart? It points us directly to this chart. So here's how you use it. It's pretty simple. You find your tank's thickest shell plate on the bottom axis, and then you find its lowest possible operating temperature on the side axis. You find where those two lines meet and plot a point. If that point lands in the safe for use zone, fantastic, you're good to go. But if it falls in the additional assessment required zone, well, then you've got to move on to the next steps. So, what happens if you do land in that additional assessment zone? That question brings us to the final part of our journey today, figuring out the tank's ultimate fitness for service. You know, the really great thing about this whole process is that it doesn't leave you guessing. There's no ambiguity. When you follow the map, you always land on a clear outcome. That outcome might be, yep, continue using the tank as is. Or it might be, you need to change the service to something less demanding. Or it could be that you have to do some specific repairs and then come back and reevaluate. And if a tank does need to be re-rated, Step 9 actually gives you some really concrete options. You can create what's called a new safe operating envelope. What does that mean? Well, it could mean you restrict how high the tank can be filled, or you set a new, warmer minimum operating temperature, or maybe you switch to a lighter product with a lower specific gravity. These are all practical, smart engineering controls that let you keep using the asset, but safely. And finally, there's a crucial reminder here that applies to the entire life of the tank, from cradle to grave. Any physical change you make, a repair, an alteration, even moving the tank, must be done in compliance with this standard. This is not optional. It is a mandatory rule, and it's there to make sure safety is never, ever compromised. So, as we wrap this up, it leaves us with a really important question to ask yourself. Is your own tank assessment process this thorough? Does it follow this kind of structured, logical path? Because at the end of the day, this flowchart, it isn't just a piece of paper. It's a proven engineering process that doesn't just save assets, it saves lives.